Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, I'd like to present my simple project research. The title, Reducing Young Coconut Waste via Pyrolysis Process into Liquid Smoke and Charcoal Briquette by Budi Rahman, Swarjaninata, and Yuli Ratna, Agrotechnology postgraduate of Siliwangi University. Introduction. Young coconut coat waste was an unused material, generally produced by burning and dumping it in landfill. This waste will result in environmental pollution problem. The solution, the waste was turned into useful material via the application 3R, reuse, recycle, and reduce. The study was aimed to determine the process of reducing coconut coat waste via pyrolysis process into liquid smoke and charcoal briquette. Experimental. The sample of young coconut coat waste was obtained from 5 different locations representing young coconut ice cellar in Tasik, Malaysia City. The waste was chopped, dried, and mixed homogeneously as a feedstock for the pyrolysis projects. The main product of pyrolysis were liquid smoke and charcoal. The liquid smoke used as present spring column shape was the result of redistillation process, so it's not contain carcinogenic compound. Charcoal powder was mixed with start to form a homogeneous mixture that was ready to compress by hydraulic press. Result and discussion. Pyrolysis of 1000 grams of young coconut coat waste as a table 1. The pyrolysis product include charcoal in gram, liquid smoke in gram, tar in gram, respectively. The percent of product for 1.88, 27.17, and 8.22. Pyrolysis product: 1 liter of crude liquid smoke as grade 3 was continued for 2 redistillation process, which produced 850 ml of food grade liquid smoke. The grade 1 of liquid smoke was tested as preservative of palm sap. The application of liquid smoke on pH depletion of coconut sap. The concentration of liquid smoke 0, 3, 4, and 5 effect to pH depletion respectively 3.7, 0.1, 0.5, and 0.3. In the control, the pH depletion of coconut sap most sharply over time. The 3% treatment gave the best reduction on the pH depletion compared the other treatment. All treatment of liquid smoke could suppress the damage of shaped by microbial activity. 2. Reducing sugar of the coconut sap. The liquid smoke concentration 0, 3, 4, and 5 affected to reducing sugar concentration percent, respectively 5.8, 0.6, 2.13, minus 0.72, and minus 0.34. All treatment provide reducing sugar level below the maximum standard, below 10%. The lower sugar content will give higher quality of sugar because it's effective in hardness, colorless, and taste. 3. Characterization of waste charcoal briquette. Test parameters include water content in percent, volatile content in percent, ash content in percent, fixed carbon content in percent, and density gram per centimeter cubic, and compression force in kilogram per centimeter square, and calorific value in calories per gram. So as in the table, the briquette had a density of 0.62 gram per centimeter cubic, which was still below the Japanese standard range. 2. The compression strength of the briquette was 32.44 kg per centimeter square, which was still below the Japanese standard. This confirms that the composition and the compression process had not met the requirement, and the calorific value of the briquette was 6.21 kilocalories per gram, which was within the range of the Japanese standard and better than the Indonesian standard. Conclusion. The pyrolysis of 1000 grams of young coconut coat waste produce charcoal, briquette, smoke, liquid smoke, and tar of 418.8 gram, 271 gram, and 82.2 gram respectively. The distilled liquid smoke was tested as a preservative for coconut sap proven to 1. Prevent a decrease of pH and suppressing reducing sugar level. Young coconut coat waste briquette were tested according to ESTM D5142-02 proven to had the properties water content, volatile content, ash content, fixed carbon content, densitas, hardness, and caloric values of 7.79%, 26.74%, 2.76%, 68.66%, 0.62 gram per centimeter cubic, 32.44 kilogram per centimeter square, and 6.21 calories per gram respectively. Thank you very much for your attention.